Okay, when you guys were watching my videos earlier, did you ever hear like a tick sound that would happen? So I think what happened is the microphone it actually like it actually kind of comes undone and tilts out, and it's just hanging on by the little electrical cords, like the little electrical wire. So what I did last night is I put it back into place. I soldered the wire, and then I actually put some hot glue to hold the microphone top in place. This thing right here is just a guard. That's all it is. So hopefully we shouldn't hear that tick anymore. If you do, let me know. But I think I fixed it. Okay, because every time I would move the mic, it would bounce around. You know, the thing on the inside would bounce around. Hopefully that doesn't happen anymore. I can see. So shake it. Okay, I'm shaking. I'm jumping. Okay. All right, very good. Oh man, you gotta wonder, like people who watch this, are they happy for the people overtly that they have me as a teacher, or do they feel bad? Like, considering reporting. Like if I checked ratemyteacher.com, like would I find a lot of negative results right now? So who knows? Actually, remember to comment and subscribe. Yeah. Some people said I should monetize these videos. I don't think there's anything too epic about it, but it's interesting that there are some that come up in the Google search more quickly than others. So there's some videos I've seen where I'm like, that really wasn't a very good video, but because it comes up in the search so quickly, like there's over 5,000 views of some of those videos. I'm like, oh, well, that's unfortunate. Oh, really? I've got it. I've got over 200. I guess I need more than that. But if I monetize it, then it shows the commercials at the beginning. I think that would be really irritating for you guys, right? And you're my number one priority. So. Ah, got it. Extra credit points for subscribing. Okay. What if I put a link to my GoFundMe page and I could make one and then what? Yeah. By the way, all those of you who take Kayla's Quizlet notes, okay, time to own up to that, okay? All right, here we go. Slightly more difficult problem. So on a scale of 1, 2, 3, or 4, I would say that we got rid of 1 and 2 yesterday, okay? I would say we can do level 1 and level 2 problems. It's time to investigate ones that are a little bit more complex. And so you look at tangent squared over secant minus 1. No, no. But this is your most difficult test of the year. And yes, I am extremely concerned about it. So, but we'll stay positive. So, oh yeah, both, 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 both. Yes, yes. I'll give you those notes on Monday. You can see exactly what you're going to get. So I'm going to do something a little bit different for you. Instead of trying to focus on the bottom, I'm going to focus on the tangent squared, and I'm going to substitute in secant squared minus 1. Now the question is that really a good option? For some people, they're like, it seems like it went backwards. It seems like you would want to take secant squared minus 1 and substitute tangent squared, but now you're going backwards. Well, I did that because the top is the difference of two squares, isn't it? The top factors. What do you multiply to get secant squared? What do you multiply to get negative 1? Oh, hey, isn't that nifty? What happens? Isn't that amazing? This one, cosine of theta plus 1 over sine squared. I'm going to do the same type of thing. We'll see if you guys know what sine squared is equal to. 1 minus cosine squared. Does 1 minus cosine squared factor? To what? Good. 1 minus cosine of theta and 1 plus cosine of theta. Those cancel, and I get 1 over 1 minus cosine of theta. That is simplified. There's not much more we can do there. Letter C doesn't have a squared at all. Could I come up with a squared? How? Secant times secant is? Awesome. Secant times cosine. What's the relationship between secant and cosine? They are reciprocals. If you multiply reciprocals, you get 1. Shoot, if only we knew what secant squared minus 1 was. Oh, it's tangent squared. Really? Who thought that? Pretty cool stuff. Sine times sine. Do I have to multiply both of them or just one of them? Just one. Sine times cosecant. That's 1, so I just got cosine squared. Oh, sine squared plus cosine squared. So sometimes people wonder, do you have to take sine times cosecant and sine times cosine squared? Right. 1 times cosine squared. People want to take, here's what people want to do. They want to leave it as sine of theta times cosine squared then. And no, you do not do that. Yes. And then the question, try again. I'm not sure I understood the question. So it would be like this. Here's what I did. Suppose you have 2 times 3 plus 1/2 times 4. Okay? I distribute the 2 to the 3, and I get 6. Distribute the 2 to this set, and I get 2 times 1/2 is 1 times 4. So if you would take 1/2 times 4, you get 2, and multiply by 2, you still get 4. But sometimes people want to say 2 times 1/2 and the 2 times the 4 to get 8. No. 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 Okay. And sometimes people ask this question, how do you go from sine squared plus cosine squared? How do you go to 1? That's like, what is the capital of the United States of America? Washington, D.C. So, so yeah, it's pretty cool. We're kind of a big deal. So 13. All right. Now I'm going to FOIL it out. 1 times 1. 1 times positive cosine will be a positive cosine. And then what? You got a negative cosine. And then negative cosine times positive cosine. Negative cosine squared. What happens? Yep, those are gone. What is 1 minus cosine squared? Sine squared. So notice that those are conjugates, aren't they? When you multiply conjugates, the middles go away. Do I have conjugates here? Yeah. So I'm going to get tangent squared minus secant squared. Huh, what is tangent squared minus secant squared? I wonder. Very good. Chris says -1. He's right. If you took the secant squared, and everybody knows that that's 1 plus tangent squared, isn't it? If you plug that in, you would get tangent squared minus the quantity 1 plus tangent squared. And you would see that the tangent squareds would go away, and when you distribute the negative, you get a -1. There's about 5 different ways to think about that problem and do it, but that's one. Do I have conjugates here? Yep. So I get 4 secant squared of theta minus 4. What to do, what to do, what to do. Take out the 4. Oh, GG. Said, oh, GG. All right, we got kind of a dilemma here. We don't have any squareds, do we? But maybe we'll create a squared. So I rewrote everything in terms of sine and cosine. So I used kind of that option that we started with right at the very beginning. And what I noticed is that the cosines canceled. Now I was left with sine of theta plus what? That's pretty cool. I came up with a square, didn't I? Squares go really well if you compare something else with it, especially like a 1 or something else. So what we're going to do is sometimes one option for reducing trigonometric expressions is to combine the fractions. And maybe it'll result in something that's useful. What is it that you need to do in order to combine two fractions? Common denominators. So I'm going to multiply the top and bottom by sine. Hey, that looks like it'll be helpful because, well, I create a squared, and squareds are always good. So I get sine squared of theta plus cosine squared of theta all over sine of theta. What is sine squared plus cosine squared? It is 1. What's 1 over sine? Boy, isn't that a beautiful problem? Okay, everybody's entitled to their own opinion. Eve, how about this? Okay, let's go to letter I. We have sine squared of theta over 1 times 1 over cosine of theta plus cosine of theta over 1. Okay? Now, I can see that I'm going to have a denominator of cosine, but in order to get that, I have to multiply the top and bottom by cosine. And that's convenient because I'm going to end up with a cosine squared. So I now have sine squared of theta plus cosine squared of theta, and that's all over, cosine of theta. Sine squared plus cosine squared, 1. And 1 over cosine. Isn't that beautiful? Now, here's the difficult piece, folks, is that, I can teach everybody how to do, 1 plus 2x is equal to 9 and to solve for x. But I can't necessarily guarantee that every person knows how to take one of these and simplify them. Sometimes that's a culmination of your mathematical problem solving abilities over the past 10 years. And so what I can do is I can expose you to as many problems as possible. So as you can see, we've already covered about 20 or 30 of these problems so far. We're going to do 3 more. And then in your assignment, you got 22 you're going to do, and on a study guide, you have some. The chances are that when you get your test, you will have seen basically every problem before. It's a matter of not whether you remember how to get through. Okay. All right. 1 minus cosine times sine times tangent. Any thoughts where to begin? Sure. 1 minus cosine of theta over 1 times sine of theta over 1 times sine of theta over cosine of theta. And there's nothing wrong with trying something and then looking at it and saying, well, do I like the result? Does it seem like it's going to go somewhere? Does this seem like it'll go anywhere for us? Or what's going to happen? So the cosines cancel. We end up with 1 minus, which is, yeah. So we've used a few different methods. The first method we used was, we're going to write things in terms of sine and cosine of theta, okay? Our second method is that sometimes we substitute something in. Our third method that we use is sometimes we like to factor or we like to distribute. And really the fourth option is combining fractions. And at the end of the day, really, you just kind of got to try and hope for the best. Because it's not always clear what's going to work out. Like letter K. Any thoughts? Okay, common denominators, let's give it a shot. What do I get in the numerator? And in the denominator, I have cosecant of x plus 1 times sine of x plus 1. Huh. Is that the same thing in the numerator as it is in the denominator? No, it's close, but it's not, is it? I mean, the top is separated by addition. The bottom is separated by multiplication. Okay, so Grace has an option, and I want to point it out. Grace says, well, turn the cosecant into 1 over sine, and then work towards finding common denominators. Turn this cosecant in terms of 1 over sine and find common denominators. She's right. That is an option. It will work. It will take us a little bit longer. There's one other thing we could try that might result in something good for us. Yeah, let's see what happens if we multiply out the denominator. I'm a bigger fan of leaving denominators alone in factored form, but one thing I see here that I like right away, and this is going to make me want to give this a shot. I just try to look ahead a little bit. Why will I end up with a 1? Yeah, will I end up with another 1? Let's see. What's cosecant times sine? What's the relationship between cosecant and sine? They're reciprocals. If you multiply reciprocals, you get 1. What's cosecant times 1? What's 1 times sine? And what's 1 times 1? Are those the same? Yeah, they're totally the same, aren't they? And let's just be clear. It's not that the cosecant crosses off with the cosecant. It's not that the sine crosses off with the sine or the 1 crosses off with 1. It's that this thing cancels off with that thing, right? That's what's happening. I mean, we can laugh about that. I mean, in other classes, it'd be like, what? But we see why that's true, right? Okay. All right, last example. Let's go with the problem blind, not knowing any idea what to do. You tell me. Any thoughts? Sure. Very good. Thank you, Olivia. Don't act surprised. Excellent. Sounds like a good idea. There's about 5 ways to do this problem, so I'm very proud of you. Common denominators? Okay. Whatever you say. Let's roll. 1 plus cosine of x. 1 plus cosine of x. Sine of x. Sine of x. So before we validate whether or not Gigi's idea was good or not, can somebody indicate to me what would possibly show that there might be some merit to this? Give me something. Yeah, we're going to get some squareds, aren't we? And so that's some good news, hopefully. So we get sine squared plus cosine of x plus cosine squared of x all over the denominator is sine of x times 1 plus cosine of x. Like I said, I don't like to multiply the denominator out. I like to leave it in factored form as much as possible. Olivia has a question. There are no stupid questions. If you have it, somebody else in the classroom does as well. Okay, thank you. Sine times sine, sine squared. Cosine times 1. Got it? All right. Now, this is the point where you have to see this or you can't get the problem right. You have to see this next piece. What's the next piece? Yeah. Sine squared plus cosine squared is 1. So in the numerator, you then have 1 plus cosine of x over sine of x times 1 plus cosine of x. So sometimes that's the part where somebody gets to a problem on the test, like, well, I'm stuck because I don't know what to do. It's like, oh, I'd really like to give you a hint, but if I did, I'd just be giving away the entire problem. So that's my point, that that's just getting used to doing the problems and recognizing. Now what happens? They sure do cancel out, and you're left with 1 over sine, and we would say that that is cosecant. I would say that that would be, kind of a level 4 type problem, in terms of what you'd be expected to do and work through. But it's a good thing. You guys are extremely intelligent, so I have no question that you'll be able to do that. Your assignment is from section 7.1, page 540, numbers 1 through 22. It is just the same assignment that I've been giving over the past couple of days. I know many of you have been gone for the state wrestling tournament. Some of you have been gone because of optional Thursday or optional Wednesday. Justin's already done with the assignment. If you need any help, check with him. And that's it. Yeah. So Grace points out that yesterday we did, like, say 1 through 6, and then like 8 through 11, and then 13 or something like that. Just finish 1 through 22. So if you haven't done some of those problems yet, then just do them all. Yeah. You may. Because somebody asked me to bring chocolates. I think his name was Lucas Peterson.